Okay, we're going to take a break from the frame assembly and jump into something a little bit different. We're going to assemble the new spring-loaded extruder that I put up on Thingiverse about 2 weeks ago now. There is a version of the spring-loaded extruder that I've had up there for several months now. I just recently updated it to make it stiffer, lighter, use a smaller bearing. It puts a little bit more force against the filament, so it's less likely to skip, and it really does a great job of driving the filament. Another thing that's really nice about this is the filament comes through this opening in the bottom, passes through here, and is fully captured. If you notice, the filament actually comes through in between these two peaks here. So there's very, very little unsupported area for the extruder and or for the filament, and that will potentially allow you to use some of the somewhat flexible filaments out there. I don't think you're going to be using the really soft stuff, but this will increase the likelihood that it'll drive, some of the somewhat flexible but still, stiff, flexible filaments that are out there. Again, it really controls your filament, and it allows the push and the retractions to occur properly. Okay, to assemble this today, we're going to need you to go to Thingiverse, print these pieces out. I'm going to link to the actual file, and the link will appear below the video here. There's going to be a total of 4 pieces you're going to need to print: the actual mount, the extruder arm, there is an extruder support piece, and then the spring plunger. You're going to need to have a couple things on hand to assemble this. This is a 5 by 15 by 5 bearing, which means the inside diameter is 5, the thickness of the bearing is 5, and the diameter is 14. This is a good stout bearing that has large balls inside it, and will be able to handle the constant pressure load that is going to be applied. It's just going to do a really good job of lasting in this particular application. As far as hardware, you're going to need some M5 by 10 screws to mount this to the frame. You're going to need a couple of M3 by 6. These are short screws. We haven't used these before in this build, and those are going to be used to mount the stepper motor to the actual mounting bracket. There's a couple of recessed holes here and here and here, and those are really kind of shallow, so we need a short screw so it doesn't bottom out inside the stepper motor's housing, and you need it to really tighten down properly. We're going to need the springs out of a 5-pack of bed leveling screws. Notice I did say a 5-pack. We want to make sure you get those. We're not going to use the 5th screw and spring for bed leveling, but we are going to use the spring for this extruder, and that's why in the bill of materials it says to get a 5-pack of these. We're going to need some 2020 hammer nuts in the M4 size, M5 size. We're going to need some of the M3 by 15 screws and 1 M3 by 20 screw. We're going to need a standard NEMA 17 stepper motor. Really, you can use any size you want, but any of these kind of normal size, I think these are the 42-inch motors. Those work really great, and like a lot of the other hardware for this build, I've sourced this one from ZYL Tech. With the hardware I have, I'm going to need to use a 3mm Allen driver and a Phillips head screwdriver in order to assemble this. Alright, let's get started. The first thing we're going to need to do is mount up some of the M5 button head screws with the hammer nuts through the top of the mount. The extruder will be oriented like this. There are some additional screws that we have that we'll assemble in advance, but we're not going to put them through because they really need to go in after we've put it on a frame. Alright, let's go ahead and mount that up. To install this in a frame, you're going to line up the hammer nuts so they can just drop in vertically here. Alright, and if you think about this, if you kind of divide your frame in half, kind of put your finger at the midpoint here, you're going to want this mount set up so that the face of this here is right about the midpoint of the midpoint, or about a quarter of the way away from the face here. And what that's going to do is once we install the spool, it'll kind of mount it in a good location so that the filament will come off the spool and up into the extruder and then over into the hot end. Okay, once you've got that, kind of just push this towards the frame from the side and down, and then you can start tightening your screws here. Just kind of get them snug, and you're going to want to look to make sure that the T-nuts have turned on both sides, and yes, they look like they have. And once you've done that, you can kind of finish snugging it the rest of the way down. Okay, you're going to feel that the screws turn for quite a bit with a little bit of tension, and they'll just kind of tighten up. But once you've gotten them tight, then you don't really need to crank them down too much more than that. Okay, now that you have these secured, we can now pass the screws through the sides. These are the openings that have the kind of rectangular openings that are sized for the T-nut. So when you push the T-nut through, it goes ahead and goes right through. And I've kind of put a recess into these now, so that when it starts to tighten up, the screw gets centered in the slot, and that really kind of does a good job of making sure that the screw is located right in the center of the slot. There we go. Make sure we got it in the right spot here. And also being recessed, it helps make sure that there's plenty of clearance for the stepper motor, so that the screw heads will not kind of interfere with the stepper motor in any way. The way I've designed this, I made it so there's about 1 millimeter of clearance all the way around. So if the stepper motor ever gets hot in use, there'll be a good amount of air kind of convection around it to allow it to cool and everything like that. The next thing we're going to need are at least 2 or 3. Might need one M3 by 10, but I think it's. I'll have to double check this 1 second here. Yep, so we're going to need one M3 by 10 screw here. I wanted to make sure we had as much material as possible available, so let me go ahead and get that screwed. Okay, in this raised boss, you're going to need to put an M3 by 10 screw to allow the threads to go through properly. And you just want to kind of put it through until the threads start to show up the other side. Now these other two are recessed, so we need to use the M3 by 6s in these locations in order to, again, make sure that in order to make sure the screw goes through into the stepper motor, but does not actually bottom out in the stepper motor before it tightens down. And again, using the M3 by 6 screws will make sure that that's just right. And now we're not going to put anything in this last one, because this screw actually functions as a pivot screw for the arm, and we'll show you how to put that together in a second. All right. The way I run this, I run the wire towards the center of the machine, but I actually have it go over the top. And the reason for that is there's not a lot of clearance down here for the XY carrier to go past and everything. So it's, there's no interference or anything like that, but I want to make sure that you never run into any situation where you get some kind of an artifact on your print because the XY carrier is rubbing against a wire. So we're just going to run the wire toward the inside of the frame so that nothing's stuck out, and then we're going to loop it over the top, and then we're going to actually tuck this into the channel on the inside, and that'll make sure that everything looks nice and hidden once we're in place there. All right, so give your stepper motor kind of a good push on here to get it to go in place, and then you can go ahead and let your screws kind of pull it in the rest of the way. All right, these are nice and snug, and I can tell that they haven't bottomed out. So they're going through about 3 millimeters of plastic, and then they are threading 3 millimeters into the stepper motor, which is going to give plenty of bite and strength there. All right, so now we have all 3 of these screws mounted. Okay. The next thing we're going to do is kind of temporarily put the MK7 gear in place. And this particular gear uses a set screw that has an M2 thread on it. So you're going to want to turn the stepper motor shaft around until you see the flat, and you're going to just temporarily kind of lock it in place for right now. Next thing we're going to do is assemble the actual arm. Holds the filament. The filament actually passes through that, and to do that, the first thing you're going to do is get your 5 by 14 by 5 bearing. You're going to slide that right over the axle for the bearing and push that down all the way until it bottoms out. And then we're going to take this support bracket. It has a little recess here, and that kind of keys onto the axle that the bearing spins on, and it locates that, prevents it from misaligning or from the pressure of the filament, deflecting or anything like that. So this bracket basically holds this bearing in place really, really rigidly. And what we're going to do is we're going to pass 3 of the M3x15 screws through these holes, and everything goes well. They'll go right through here and then stop just short of the other side. Okay, and then that'll make sure that you have maximum rigidity. So there's a screw that's going all the way through here, and we're not relying on just a 3D printed shaft to hold the bearing in place. Sometimes I like to cheat and use a drill. Obviously don't overdo it, but if you've got to put a long screw in, this is really kind of helpful. I get it so it's most of the way in there. Go at a nice low RPM, because if you go fast, it'll generate heat and it'll melt the plastic and it could strip out. So once I've got it so it's almost all the way through, I will finish it off with the hand screwdriver, just till it's snug. And look at that, you gotta love Fusion 360 when you draw stuff in 3D and everything fits exactly what you want. I made this thing 60 millimeters thick and I used 15 millimeter screws, so everything fits exactly like it's supposed to. Alright, now what we're going to do is we're going to take our bed leveling assembly and we're going to swipe a spring out of that. And one of the parts that we printed is this little piece right here. It's got a plunger and it's sized so that the spring kind of sits right on it, and we kind of push that into this hole right at the top. And what we're going to do now is take a M3x20 screw. We're going to put this through a hole that's right in the bottom of this, and we're going to thread that in. And as it goes, it's actually going to go into a small pocket at the very bottom of the extruder boss. And what that'll do is it kind of threads into the bottom of that little mount basically for the spring, and that will allow you over time to kind of adjust that up and down in tension. And we're just going to kind of lower the tension a little bit. You can see it kind of went down. You can see it about halfway through. That's about the bottom point for the tension setting. Okay, the next thing we're going to do is we have to mount the bowden adapter. There's actually like a 4.75 millimeter, almost 5 millimeter hole here, and it's a little bit on the undersized side because people have different bowden adapters. So it's really important to kind of make it a little bit small, and if you need to make it a little bit bigger for your adapter, just carefully use like an X-Acto knife or a drill bit that's the right size for the threads that you need to use, and open that hole up a little bit. Let me go ahead and get the bowden adapter in there and we'll go from there. Okay, so here we have a fairly standard bowden adapter. The diameter of this thing's just a little bit over 5 millimeters. I don't know if it's like a made-up thread or something like that. It looks pretty coarse. There's a lot of different sizes of these, and we want to make sure that whenever I kind of design something like this, I want to make sure that the opening is a little undersized. And if you need to make it a little bit bigger, you can kind of chamfer it by using like an X-Acto knife and kind of going around the perimeter of it a little bit and kind of just shaving a taper into it that makes it easier for the threads to kind of get started. And it's just kind of one of those things where you kind of want to trial and error it a little bit to get it started. And once you got it, it should just thread itself in fairly easily. Now you want to make sure that it stays vertical this way and vertical this way so that there's no kink of any kind. It'll straighten itself out a little bit once it bottoms out, but you don't want to rely on that because these are brass, and the wall where the threads are, like the thickness of the wall of material between the threads and the center part where the hole for the bowden tube goes through is really thin, and if you try to force it, you can break it. Don't ask me how I know that. But yeah, you just want to carefully kind of tighten this thing down and make sure that it's nice and straight. And I just kind of hold it still and turn it down and keep going until I just get it snug down. Don't go too far here. And that looks good. All right, it's nice and square this way and nice and square this way. Now, one thing I did to prep this before I assembled it and before I put this screw here is I took a 5/64 drill bit, or a 2mm drill bit. 5/64 is almost exactly 2 millimeters. So, and just by hand, I kind of passed it through and then turned it to make sure that if there were any kind of little loops or anything of filament that kind of made it into the where the filament needed to pass through, it would go ahead and clean all that up and give me a very constant 2mm hole. Our filament is 2.75 with a 2mm hole. I kind of designed it to be 2 millimeters when it printed. It's going to be a tiny bit tighter than that, but by passing that drill bit through from one end to the other, it makes sure that it's perfectly aligned and that there's no little loops or anything of filament that would snag on it and kind of keep it from moving freely. I want to demonstrate how this works. Okay, so there's an opening down at the bottom here that has a 2mm hole, and it has a little bit of a radius flare there so that it can kind of get the filament in from multiple angles. And then it goes past the bearing right there into the hole and comes right out of the top for the bowden extruder and everything. Now, the nice thing again about this is that the bearing pushes against this, and it's really going to crush it against the MK7 gear. The whole thing basically pivots like this. So if you ever need to change filaments, all you need to do is push down on this lever and then pull down, and then you can pull the filament right out of your hot end. Let's go ahead and mount this up onto the actual extruder mount here. And to do that, we're going to need an M5/20 screw. And notice that even though the arm is 16 millimeters thick, I've actually recessed this boss down 6 millimeters, so the screw will go all the way through here and stick past. It'll stick out 10 millimeters. 5 millimeters of that is going to be the thickness of the actual extruder mount, and then 5 millimeters is how far it's going to thread into the actual motor, and it should bottom out. And again, I designed this to bottom out so that when you crank this down really tight, it still allows it to move up and down freely. Okay. Now, to get it in place, you need to back this off just a little bit. All right, and we're going to kind of get it started in the hole for the extruder right there, and make sure that the spring is in a little pocket. There's actually a little recessed pocket here to capture the spring that I designed into the part, and it'll sit just like that. Okay, and like before, I'm going to run it most of the way through. All right. And that looked pretty good actually. So I'm going to make sure that it's torqued in. Yep. Now notice that it's a little bit loose right now. We need to actually tighten up the spring so that it puts the proper amount of preload on it. And I'm going to go ahead and do that now. And I usually set it so there's about 3 millimeters of space down at the bottom there. And now you can see kind of how it functions. Okay. The last thing we need to do is kind of adjust where the notched part of the MK7 gear actually is in relation to the extruder. So what we're going to do is we're going to loosen it I'm just going to spin it around here until I can see the screw, and you can kind of pass it through right here. And I'm going to loosen that a little bit so it can move in and out. And then I'm actually going to pass the filament through here. And that filament, believe it or not, when you actually rotate it around, it will make sure, it'll actually center the extruder gear exactly where it needs to be. Okay? And again, if you just kind of pull it up and down a couple times, you'll notice that the extruder gear will, since the part where the teeth are actually have a little bit of a dish, it's going to center itself over the thickness of the filament, and then that's exactly where you want it to be. So I'm going to go ahead and put the Allen key through here and tighten it down. Nice and snug. Alright. So now, as I rotate it, you notice that the stepper motor will actually rotate too. And it's nice and smooth. And then when you push down, it comes out nice and easy. Alright. Well, that, my friends, is the assembly of the new spring-loaded extruder. This is a nice, reliable direct drive unit. It works really, really well. You can print pretty fast with it. If you want to do printing speeds that are much more than maybe 60 to 75 millimeters a second, you're going to want to maybe put a little bit of a longer stepper motor on this, and then run your stepper driver voltage, reference voltage, a little bit higher. I normally run mine, right around 0.6 to 0.7 volts. You don't really need a lot of power, for most of these extruders. But if you notice that your filament is starting to thin out, like when you're going at high speeds, you can increase the voltage, but monitor the temperature. These little motors, like these particular ones that are about, I think they're about 42 inch ounces, they'll start getting hot because you're asking it to go faster. It just doesn't have the torque that it needs to really do that. So you can go to a longer version of the motor that has more torque. I think there's like a 56 inch ounce version that's about 12 millimeters longer, and then you can run a little bit higher reference voltage with that, as long as you have active cooling on your stepper driver. And then beyond that, if you want to go into the 100, 150 millimeter, or consistent printing all the time at like 75, 80 millimeters a second, you might want to look at a geared extruder. I actually, on my own personal printer, I use a Bondtech BMG. They're kind of expensive. They're about 90 bucks, but they work really great, and there really is no limit that I've ever seen as far as how fast it could continue to push filament through, so that's pretty impressive. But again, this is a very low-cost alternative, and it really works great.